everyone, Radhe Radhe. My name is Ayan Pasha. I'm the Cloud Native Developer Advocate and continuing our playlist about the orchestration and the observability playlist and the Kubernetes playlist in Cloud Native. Today we'll be learning about a really interesting topic that is about the gateway APIs. In the last topic, if you haven't seen my video, then we discussed about the Ingress, how Ingress is really helpful in monitoring the traffic that is actually flowing between our clusters and the users that are asking for those particular requests at the moment. Ingress can help in configuring the different, the controllers as well as the various different components and services of our cluster at the moment. And the gateway APIs are actually being used by a lot of companies, by a lot of projects because of its benefits over the Ingress. So in the last video, we took an example of VIA and watch. Those who haven't seen that particular video, they can watch my video. Otherwise, as a prefix, as a the context, we took an example where we had two services in our application, that was the watch and the other one was the viewer. Let's say the Amazon.com, that is for the shopping purposes, and the other one was the Amazon Prime videos. So it will be considered as the watch section or the watch service of our application, and the other one would be kept particularly for the shopping purposes. So these both different services would be handled differently. So in that case, if the our whole application is actually being managed as a single resource, and those are actually being distributed onto the various different services, then Ingress won't help you in distributing your system according to the different services. If there are different teams that are working on different sections, then there are really high chances that they might have some kind of, they will have a lot of problems while working together, because they will have to manage the correlation between the different teams as well, and it would be a really hectic and tedious kind of work. So that's why gateway APIs usually came into the existence. Gateway APIs are usually considered as a better model of the Kubernetes, handling of the as a load balancer, Ingress, service mesh, and various other techniques as well. It usually builds and acts as helps onto both the layers, that is layer 4 and layer 7 of OSI model. And for instance, if you ask me, then the Ingress doesn't have any multi-tenancy support. If the your organization is having a lot of different teams, then they can't be handled separately, and they might have certain kind, they might stuck in a certain kind of a loop, or any the core between all of those particular teams. There are no namespace isolations, there are no resource isolations as well. Neither the role-based access controls has been promoted by the Ingress. So that's why it really pissed off the developers and all the people who really gave their time and a lot of knowledge and resources for their project. So that's why gateway APIs usually came into the existence. Gateway API is the next generation or the replacement of the Ingress, load balancer, and the service mesh in the Kubernetes. It has better multi-tenancy support. It's also clean separation of responsibilities has been distributed to all the different parts of your amongst between on your organization. Role-based access control has been provided, isolation of the resources as well as of the namespaces in your cluster, native support for many features like the TCP calls, scanner deployments, and various other features have been provided to you by the help of gateway APIs. And the controllers which implements the gateway APIs are like you heard in the last video that the Ingress is usually being supported with the help of controllers. We have to set them up. Similarly in the gateway APIs as well, we have to set up the controllers in our system. The various different controllers that manages and have adopted or implemented the gateway APIs in their infrastructure are the Nginx, Contour, Traffic, and HA proxy that you might have heard in the last video as well. But the really interesting ones are the Istio, Cilium Gateway API, GlueMesh and the K Gateway API, and the Kuma and Com. If you are really keen about the Glue Gateway, GlueMesh as well as about the K Gateway project, they have also been succeeded in becoming this CNCF sandbox project recently. I've also had a chance to get a meeting with the VP, Vice President of the open source, that is with the Lin Sang of Solar.io. So I might check that particular video as well. Gateway API is usually being structured, or it has various different components. It is being broken in three different parts. There's the gateway class, another one is the gateway, and the third one is the HTTP routes. So the let's come on to all those particular parts one by one. So the gateway class is usually acts as the blueprint of your application at the moment, like the how that particular car will going to work. Certain engineers usually implement those features afterwards, but before that you will have to get all on with the planning. Like you have to come up with a kind of a blueprint, otherwise your engineers will act in the similar way. Your gateway will be defined on the basis of the gateway class that you have implemented, and then the gateway will be laid on that particular uh, the blueprint that your engineers have implemented earlier. So gateway class is usually implemented by the help of infrastructure providers, which can be done with the help of the Nginx and Envoy traffic and various other solutions as well. And then we have the gateway. Gateway does the real work of working alongside the blueprint that has been laid by the engineers, by the infrastructure providers. Gateways are actually being built or being handled with the help of the the cluster operators in our case. So the gateways usually helps in it deploys the cluster and actually listens on the IPs and the ports and defines the TLS settings as well, and decides which traffic came into our cluster, and then which namespaces are they have to be can they use or have to be routed further, which can be handled with the help of the HTTP route in the next session. So it will be managing various different the actions as well, like which namespace can it route to, which kind of traffic is actually being coming or being received from the from the user that has requested to our application. That is whether it is about the TLS or HTTP or the TCP protocol that has been used by that particular request that has been sent to us. And then we can also list out the listeners, like the ports, host names, protocols to support that particular request that has been uh, patched to us to our cluster for using any particular service at the moment. So that was all about the gateway and gateway classes. Next one is the HTTP routes. HTTP routes are actually, you can consider them once the traffic have been selected, like yeah, you can enter to our application that has been checked by the gateways. Gateways which were built on the top of the gateway classes. Once they are being checked with the help of gateways, then they are actually being handled by the HTTP routes to get forwarded to any particular service or any particular resource that is being found into your particular application at the moment. That is the HTTP route. So HTTP route will be providing a kind of a route to your to your request at the moment, and that route will be set between the user or between the node port, any particular port that from where that request has been coming onto the service that has been requested for, and then that service will be forwarding a request to the pod or the container that you might have requested for. You get the point what I'm trying to say. Uh, Unlike Ingress, Ingress usually provides you only with the HTTP routes, HTTP protocol. You can only handle the HTTP protocol in case of the Ingress, but in the case of gateways, you have a lot of different protocols. Major three are the TCP routes or the gRPC, and the other one is the TLS route. So that's all most of the developers usually opt for. Otherwise, if you are a backend and the network engineer, you might have a lot more to work with. Right, so that was all about the three different components of the gateway APIs, of the gateway class, gateway API, uh, gateway APIs. That was the gateway class, and the other one was the HTTP routes. HTTP routes isn't all solely being given like only HTTP routes exist. We usually have various different protocols as well that are actually being followed in our case. Majorly there are HTTP routes, TCP route, and the gRPC routes. And there are various different the functions that are actually being handled with the help of gateway APIs. Like the Ingress lacks native support for various different the functionalities which are the TCP and UDP routing, header manipulation, traffic splitting, and the course part as well. And the custom error pages, session affinity, WebSocket support, auth, and the rate limiting redirects and various other functionalities as well. Right. So, please at the moment. Alright, so the TLS and alright, so there are various other functionalities as well that are being provided with the help of the gateway APIs that were really tedious while implementing with the help of the Ingress. Whether it's about the Canada deployment, if you don't know about the Canada deployment, Canada you can consider it if any particular update that is actually being adopted by your application. You are going on to update or push your application to a newer version, to a newer the updated version, let's say the V2 at the moment, and you are running V1 at the moment in your application for the users that are using your application. So you don't want your application to stop for a moment, and then each and every particular pod that is present on your application will get pushed or onto the version 2, and then only your users can use it. It will create a lot of time gap, and it won't be a really nice experience, or the user experience, you might say, also the developer experience as well. So yeah, so that's why some parts or some particular the ratio is actually a ratio of the traffic has been diverted to the version 2, that is the updated version, so that you can work on the any particular feedback that you might have got from the users who were using the version 2. Otherwise rest of the users can opt or can work with the real version 1 while the whole infrastructure is getting updated to the version 2, to the new version of the updated version at the moment. Yeah. So then we have the core support. The Ingress usually have the control in the earlier versions of the Ingress. We usually have the controller specific annotations for using the course advanced core settings, and which was later cleared with the help of gateway APIs. Gateway APIs usually configure them certainly with no annotations needed, and everything is being defined in the spec section of your application at the moment. And the gateway APIs configure them centrally with no annotations, and headers are explicitly defined using the response header modifiers that we will use in our application at the moment, in the example that we will be taking right now in the lab session. And also the TLS and portability, carry deployment, course, and all of these particular features are actually being adopted as a kind of the built-in feature in the gateway API. That's why the gateway APIs are highly recommended, because gateway APIs are they doesn't have any problem while implementing various different configurations. Ingress, on the other hand, was having a lot of trouble, because they had so many solutions. They had the Nginx, they had Istio as well, and Contour, Traffics, and then the HA proxy and various other solutions as well. All of those particular solutions had different the configurations, and why when they were pushed onto the Kubernetes, then the lower or the underlying components or the controllers of Kubernetes, they didn't know about those particular configurations that were being pushed along with the uh, you know our our ingresses. So that's why they used to create a lot of problems. That's why the gateway APIs were actually being adopted. Instead of them, they had a simple syntax. They had a simple, the rules and everything was actually being adopted as an inbuilt feature. So that's why they didn't have much problem while playing around with these particular features of Canada Plan and these other things. So yeah, that was all about the gateway APIs. Now we'll move on to the lab session. Now we'll be continuing our session of the exploring about the gateway APIs, and we'll try to get our hands dirty with the environment at the moment with the lab session. So here we have our Kubernetes cluster being set up with different resources at the moment. If you want to see them, we have certain pods that are running at the moment in our cluster that are being implemented or being pushed with the help of whether it is about the general pod definition file or the deployment file replica sets or the ingress controller and all these particular things. We have a lot of
files that were being written by me uh, about the various different the configuration files about various different resources of our Kubernetes system. So right now we are discussing about the gateway APIs, and let me show you some of the configuration files of Ingress as well. While we will be talking about the gateway APIs, let's take about the Ingress. Yeah, let's see which Ingress files are running at the moment in our cluster. kubectl get Ingress. Where this particular file, it is an having host, and a particular host can address it. Any role-based access control hasn't been applied to it. They didn't have either. Alright, so let's try to understand about the ingress controller. Uh, how ingress file. Yep. Oh yeah, yeah. So here we have our ingress file. Its name is Ingress, here watch, default, and these are the ports that are being exposed to our application at the moment. It isn't, these are the endpoints. If we really want to know about this whole particular file, then we might also, let's try to understand about the ingress from the general file that we have. Maybe, yeah, this one. All right, so we have gen various name, yeah. There's everything about the ingress file that we posted earlier in the last lecture. There is in ingress clear watch. It doesn't have any label. Namespace is just default. These are the posts that are actually being exposed with the help of this particular resource. And these are both of those particular hosts which were managing our application, all the traffic that were actually being flowing to our cluster. That was beer.myonlinestore.com, and the other one was watch.myonlinestore.com. These were actually being built on top of the prefix, so that's why they are being handled with the help of the prefix part type, and then in the service name VS service, and there is the lot service, and the number of the port, there is the port number is about 80. We also discussed about the various services, whether it's about the node port or about the cluster IP or about the load balancing services as well. Load balancing were solely, being given with the help of the various cloud providers, whether it's about the GCP, AWS, Azure, or the Alibaba Cloud, or various other cloud services that are available for your application. For the normal people, and they can opt for various other solutions as well. And for configuring these particular those particular solutions to our cluster and attaching, I mean, like implementing and configuring the SSL certificates and various other things as well, we used Ingress in that particular case. Let's try to learn something about our gateway class as well right now. Okay, kubectl get gateway. So here we have two gateways. One of them is the example gateway, and the other one is the secure gateway. Example gateway is the simple application that simple gateway. The file that I built, a simple gateway resource that I built earlier in order to explain you about this particular, the concept. kubectl describe example gateway. Let's take about the example gateway first of all. I think I need to write about gateway as well. So here we have our whole file about the gateway APIs. First one, the name, example gateway, and then the namespace is default. It doesn't have any namespace at the moment. Then the labels, annotations, and the API version is this gateway.networking kubernetes.io/v1. Then the kind is gateway, metadata. Alright, so one more thing, the API version of gateways is something else. It's the gateway .networking kubernetes.io/v1. It isn't same like the Ingress. Ingress had only the networking kubernetes.io/v1. It is a part of networking layer. It is part of the networking. The file or the our the part of our Kubernetes. So that's why it's a part of the networking of our Kubernetes. Kind is gateway, and one is the metadata. It will tell everything about the our application, our the gateway file that we built. earlier is the metadata. Creation timestamp is this particular time. Generation is only one. And then the resource version is this UID, that's the user ID, and then the specific gateway class name is example class, allowed routes, namespaces from same name is HTTP, AT, HTTP, for these particular files I have said earlier, and most of the things are waiting for the controller because I didn't set any controller at that moment. So that's why it's been waiting for the controller. As I said, just like the ingress, we usually have to implement and attach our controller file as well in the gateways as well. So, let's try to understand about the another gateway. Sorry, which were the particular gateways that we have? Secure gateway this time. Right. So the Kubernetes kubectl describe secure gateway. We have the whole file about the secure gateway. Is the other file that I built. The name is secure gateway. Namespace has been allocated to the default because I didn't attach it or been pushed it onto some other namespace that we built earlier. We had the labels, annotations, API version, same as the previous example, kind, metadata, timestamp. Stack is example GC. I took the same example, so that's why it's been taking the same gateway class name. Listeners allowed routes is group is gateway.networking.kubernetes.io. It's all same. Uh, the only other thing is that secret, so that's why I have also attached this TLS certificates as well. TLS certificates refs I along with my file, along with my gateway file. So it has a certain group, different kind. There is secret. I also posted a secret in this particular file. So that's why it's been showing secret. Then the name, TLS secret, and the mode is terminate status. All right. We had various different files as well that we built over the gateway. I think, yes, let's see about the traffic split gateway. We talked about the canary deployment, so that's why we'll be looking into the canary deployment as well. Now, let's look at the configuration file itself. Right. So this is the configuration file or the traffic split of gateways. And the API version is gateway.networking.kubernetes.io/1, as I said earlier. The kind is FTP route, metadata, name, split traffic, spec is the are the particular things that will be defining our the gateway. The spec parent ref is the name of the app gateway, and the rules have been set around how our gateway will be you know pushing various different actions or triggering various different actions in our cluster. Rules, backend reps. Name is we had two different backend reps or backend services that were running in our application. First one of them is the app V1 and the other one is app V2. We push them out of the same port number, but we assign them different weights. Like if the V1 application is handling 80% of the application of the traffic that are coming into our cluster at the moment, then the other one, that is the V2 application, will be handling 20% of them automatically. So that was all about the traffic split. Let's try to understand about the codes as well. All right. So uh, let's see our course file as well. All right. So course is usually helpful in sharing our resources, sharing our various actions and resources of our gateway files of our application, various different services as well, along with the different parts of your, the resources that are being pushed onto your cluster. So API version, gateway.networking.kubernetes.io. I don't have to explain about them all. We had filters. Type is being set to response header modifier. Our header is actually being handled with the help of these particular files, these particular the types or these particular things that I've explained about. The type is response header modifier. Another one is the response header modifier. And then the name access control allow origin. It will check which it will check any particular domain that has been set in our application. Like in the access control allow origin, I've entered this particular domain name. So it will be handling all the requests that will be coming to our cluster at the moment. And then the name is for the access control allow methods. Which particular methods of the APIs will be allowed by this gateway APIs? Get, post, put, delete options, all of these particular options or the actions about the APIs while implementing or while building any particular API. Then the name for the access control allow headers is the content type, and the authorization. It will be handling both of those particular things. And the other one is access control allow credentials. So will it be allowing credentials to our applications or not? So if it is true, then we can't put slash here. I mean the asterisk. So asterisk usually allows or every particular domain that has been pushed for our application for with along with our request to get more handled with our application. So we can't use the asterisk sign if it is true. And then the access control maximum age. So this particular age is in the seconds. So that's why 3600 seconds means 60 minutes and 1 hour. So 1 hour is the whole access control maximum age. The same request can't be handled for 1 hour if it is being processed for once. And the backend rest is the name and the API service port facility. So this whole course and the earlier one that was the traffic splitting, both of those were the HTTP routes. And let's try to understand about some other things as well. I think I have pushed some other classes, some other thing. Yeah, gateway class. We haven't talked about the gateway class right now till now. So let's try to understand about the gateway class as well. Yeah, it's all about the gateway class. It is about the the easier example that I took earlier. That was the gateway class and the HTTP routes. All it's the gateway class of those particular files. API version gate is same. Kind is gateway class, metadata name example class, and then the spec controller name. It's this particular thing. So any particular file that or the gateway class or any HTTP route that was actually being implemented to our application that were referring to this example class, if you might have, if you can recognize. So they all were, referring to this particular gateway class or the blueprint that were actually being laid earlier in our application, in our infrastructure. So the gateway classes are being implemented with the help of the infrastructure providers. Gateways are being implemented with the help of the cluster operators and the HTTP routes, HTTP routes, TCP routes, gRPC routes, or any particular other kind of routes are actually being implemented or being built with the help of the application developers, because the application developers are the ones which will be handling with those traffic or the requests that are actually being forwarded to us with the help of after being processed, after being authorized or authenticated, they are being checked by the gateways of yeah, gateways by one of the on the basis of the blueprints that were actually being built by the gateway classes. So that's the whole story that I've been trying to put or explain from the start. So yeah, that was all about the gateway classes. In the next lectures, we'll be trying to learn more about the certain solutions and projects of the gateway APIs. Uh, I think we'll be taking the Selenium gateway APIs. I think Selenium gateway APIs and the K gateway and and gateways and yeah, the Kuma as well. Yeah, Kuma from Com. And these are some of my favorite gateway APIs. So that's why we'll be talking about all these particular solutions. And then in the next lecture, we'll try to learn about some more resources, some more components of Kubernetes. Uh, so if you like the video, hit like, share, subscribe. So yeah, Radhe Radhe.